Good morning, class. In our last class, we have studied about the periodic table and we have got a general idea about the table. We came to know what are groups, we came to know what are periods, how many groups and periods are there. After that, we came to know about the important groups, then periods, element, okay, and all this thing we have completed in our last class. Now, today we are going to see. Suppose if an element is given to you, how to find where does it exactly place in the periodic table. Say for example carbon. Okay. So carbon element is placed in which group and in which period and it belongs to which group. Which group, which period and which block. Sorry, okay, block. Whether it is S, P, D or F block elements. Okay. So we are going to learn about it. So a period is determined by the number of cells and the group is identified by the number of electrons present in the outermost cell. This is a general statement through which we can predict the group and period. Say for example, for S block element, if you have got an S block element means when you write down the electronic configuration, the last electron will go into S orbital. Similarly with P block element also, the last electron will go into the P orbital, and if the last electron is going into D orbital, then it is a D block element. Okay, so for S block elements, group number is equal to the number of valence electron. So whatever number is present in the valence electron, say for example this N represents the number, it can be 1, 2, 3. Okay, so if it is 1s, okay, 1 is 1, so the valence electron that is 1 present in the S orbital will be the group number. Similarly for P block elements, group number is equal to the 10 plus the number of valence electron. That means when you write down the electronic configurations, it can come like this: 3s2 3s2 3p4. Okay, 3s2 3p4. In that you need to total the number of valence electron and you need to add 10. Okay, we'll see with the example that will clear you more. For D block elements, group number is equal to the number of electrons in n-1d and ns subcells. So here also we need to add the electrons present in this D orbital and S orbital to get the group number. Okay, this rule will be very clear with an example. Okay, say for example I have given you 3 examples in which I have taken one element from S block, other element for P block and another one from the D block. Okay, so the first is sodium with atomic number 11. So when you write down the electronic configuration, we write it as 1s2 2s2 2p6 3s1. Please note that this small letters number are written in the power of these orbitals. Okay, so 1s2 2s2 2p6 3s1. Now from this you need to predict to which group and which period it belongs. So over here, since the last orbital is S orbital and it has got one electron in the outermost, you can see one electron, 3s1, so that one will be the group number, so it belongs to group 1. Period. To predict the period, you have to take the outermost valence orbital. So over here it is 3s, that means this 3 is the outermost orbital, and because of that 3, the period it will belongs to will be 3, period 3, and block will belong to S block. Why? Because the last electron is going into S orbital. Okay, so in this way you have to predict the group, period and block. Similarly, we'll see for chlorine with atomic number 17. We'll write down the electronic configuration first. Now for the group number, since it is P block element, the last electron is going into P orbital, so what you need to do is we need to add this 2, 3s and 3p electron. Here we have got 2 and here we have got 5, so 2 plus 5 is 7, and this 7 is added to 10. This is in the rule, because if the elements belong to P block element, you need to add 10. So 10 plus 7 will give you 17. That means this element will belong to group 17. And period it is 3. Why? Because the last orbital is 3. Okay, and block, it belongs to p block. Similarly, with d block element, we'll see one example, chromium with atomic number 24. We'll write down the electronic configuration first: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Okay, now in this case the group number will be this one, 3d, the electron present in 3d and 4s, because it is n minus 1 d and this is ns. So 5 minus 1 is 6, so group number will be 6. Okay, so chromium belongs to group 6. And period, since the last orbital is 4 is, that is 4, it belongs to period 4. And block, it is d orbital, because the last orbital is d. Okay, based on the similar concept, okay, I've given you the assignment, that will be assignment number 25. Question number 1 is, write the electronic configuration of elements with atomic number 3, 9, 15, 18 and 20. Find their group, period and block to which they belong in the periodic table. So the atomic number of the elements are given. The first thing that you need to know is, you write down the electronic configuration. From there you can need to predict group, period and to which block they belong. Okay, so question number 2 is, outer electronic configuration of the atoms of 4 elements are given below. Okay, so the outer electronic configuration of the elements are given: 3d0, 4s1, 3s2, 3p5, 4s2, 4p6 and 3d8, 4s2. Now from this you need to identify each of these electronic configuration elements to which group and period of the periodic table are they situated or they belong. Okay, and question number 3, we have got 3 elements A, B and C have atomic number Z, Z plus 2 and Z plus 3. So this is an assumption. Okay, A has got atomic number Z, B has got Z plus 2 and C has got Z plus 3. Now among these, C is an alkali metal. That means the last element is alkali metal. That means it has got 1 electron in the outermost. To which groups of the periodic table do the elements A and B belong? Suppose if this is an C is an alkali metal, then Z plus 2, okay, that means it will belong to the element. Okay, it will belong to the element with atomic number 1 less, and Z with atomic number 2 less. Like that you need to predict, and to which period, to which groups and period do the elements A, B and C, sorry, A, B and A and B belongs, because C is known, it is alkali metal, so it will belong to group 1. Okay, fine. So complete this assignment and send it in my mail.